Hey everyone, this is Big Face from Big Face Robotics, and you're looking at my latest robot project, which I'm hoping will become a gardening robot. You may have seen some of my previous videos where I built a mobile robot, and that project evolved into me trying to make a robot that can help in the garden and drive around to the various flower beds and areas containing plants and check soil moistures and various other things like that. I put that project on hold because I found it was getting very complicated in getting the robot to actually navigate to the areas it's needed. So I've taken a bit of a different approach, and this is it. So I'll take you through the details of this in a second, but I just wanted to cover off why I'm doing this. I've become quite fascinated with the idea of a robot that can operate in the garden and help with growing plants. There are a few other products out there, the main one being FarmBot, which I think is a very good, efficient design for what it's achieving, and I wanted to build my own take on that. So I've set a couple of goals for this project, and one of the things that I think may put people off of a product like FarmBot is the initial cost to set up. So I've set myself a target of being able to build this robot for around £250, and that's going to be quite a challenge to get all the functionality in for that sort of cost, and I'm pricing it up as I go along, and at the end I'm going to see if I've managed to achieve that goal. The second target I've got is to have minimal infrastructure required in the garden to actually put a robot down and get it operating. And the third sort of constraint I'm working towards is having as simple a robot as possible. So reduce complexity and hopefully increase reliability on the back of that. So that's why I'm doing this project, and I'm going to take you through in a bit more detail now where I've got to and what the next steps are going to be. So I'll start with the chassis of the robot, and you can see it's a two-wheeled base, and under here you'll see there is a continuous rotation servo driving a gear that's connected to another gear on the main axle under there, and both wheels are coupled to the axle so they both turn at the same speed. Moving up, you'll see the base plate and the 3D printed shaped parts that sit against this steel rail, and this rail is serving two purposes. One, it keeps the robot travelling in a straight line, but it's also there to actually stop the robot tipping over. So I've obviously got a wheel either side and a contact point with the rail here, and that actually stops the robot from tipping side to side, and it forms a reasonably sturdy base for the robot. Now, in terms of putting this robot into a garden, this would be the infrastructure requirements: a piece of wood and a 25mm diameter piece of steel tube, and this could drop into any area of the garden, and that would be all that you'd need to install to get this robot up and running. So the robot can traverse up and down this rail. The wheels obviously run on the wood, and the steel tube keeps the robot base sturdy. Moving up to the top plate of the chassis, another continuous rotation servo coupled to a large drive gear that has connected to it another piece of this 25mm diameter steel tube, and that forms the rotate portion of the robot, and that can turn the whole thing around. Going up, you'll see these rack gears. I've 3D printed these, and these form the lift portion of the robot. And you'll see a drive gear connected to another continuous rotation servo. Around the back of this lift carriage, you'll see some shaped rollers with bearings, and that forms a kind of carriage that runs up and down the tube using the rack and pinion gear. So connected to that, I've got a piece of copper tube for now, because it was about the right size, and it's what I could find to do the job. And that's the arm of the robot, if you like. And to this end, we'll fix any tools or instruments that the robot will use to do its job. I've also got a camera mounted to the robot arm. This is just a standard servo with a standard webcam connected for now, and that can obviously turn, and that's the only degrees of freedom I think I need on the camera at the moment. So obviously the camera can look at the end of the arm, at whatever may be hanging off here, and can obviously angle down to look at the ground that the robot will be working on. Electronics wise, I've put a nice connection box on the back, and I've just got the servos and power connected in there at the moment. And just for testing, I've got an Arduino Nano and a power supply, and that's pretty much all I've got at the moment. I'm running this off my PC, so I'll connect up the camera and the Arduino to actually get this robot to do something, and I'll show you that in a second. So there we go, that is the current status of the robot project, and I'll show you it moving in a second. So there we go. So before we do the test run, I'll just go through the power as I'm hooking everything up here. I've got a 12 volt battery. I'm stepping this down to 5 volts to power the servos. The Arduino is just being powered from the USB from the PC, and I'll hook the camera up to my PC as well for a minute. Ultimately, I imagine I will use a main supply to a 12 volt power supply and use that to provide power to everything. And I'll have a nice connection box with the Arduino power supplies and a Raspberry Pi contained within for the image processing. So there we go, the various axes of the robot all move as they should. So the carriage, you can see that was moving along the rail quite nicely, and the rotate and lift portion do work. The lift drive arrangement may need a little bit of work. It works quite nicely and will probably be adequate, but there's a bit of play in it that I might need to engineer out at some point. But overall, mechanically, it seems to be working as it should. So next steps of this project, you'll notice that there isn't any feedback on any of these axes of movement, the carriage, the rotate or the lift, and that's because I've got an idea to use the camera for actually positioning the robot, maybe using some type of markers distributed strategically around the robot and its environment. That's the plan. So rather than fitting encoders to everything, that's how I'm going to do the robot positioning. Hopefully, we'll see if that works. There's also a bit of work to do on the design, because obviously this, as it stands at the moment, probably wouldn't survive in an outdoor environment. So there's some consideration needs to be given to waterproofing various parts of the robot. Obviously, we've got a nice connection box back there, but all of the other connections wouldn't last very long outdoors, and neither would the servos in their current arrangement. So that's something I'm going to need to consider, but I'm building this as a proof of concept at the moment, and if I can get everything working as it should, I'll then circle back and try and get the robot to a point where it can work and live outside. I'm also going to need to consider what attaches to the end of this arm. Again, looking at the functionality of things like FarmBot, it can plant seeds, it can water the plants, it can check soil moisture. So obviously that's going to be my goal, is to try and replicate some of those functions. and as such I'm going to have to design the systems and mechanically build them. So that'll be coming up at some point, but for now I just need to work on getting the robot working and able to position the end of the arm before I can consider any other functionality. So that's what I'm going to be working on in the next video. So come back soon, I'll be back with an update, and yeah, that's my new robot. So I'll leave it there for this video, and as always, thank you for watching.